Hello guys, this is Yaroslav from Gateway IT. Today I'm going to show you how to configure site-to-site OpenVPN tunnel on OPNSense, your favorite open source firewall. For the purposes of this video, I'll cover two possible use cases. First one is when you have to create a tunnel between OPNSense and pfSense. And the second use case, as you could already guess, would be between two OPNSense devices. And in the first use case, our FreeBSD VM over here has to connect to the Debian VM behind the pfSense box, while being on the OPNSense internal network. In the second use case, our FreeBSD VM1 will have to connect to a FreeBSD VM2, both being behind two different OPNSense boxes. Before you even begin the VPN configuration, you'll have to make sure that there are no overlapping internal networks on any of your firewalls. And I'll show you this on my example. Let's go to Interfaces, LAN, and scroll all the way down where we see the internal IP address range. In my case, it's 192.168.10/24. On the pfSense side, go to Interface, LAN, scroll all the way down and check the IP address for your LAN network, which in my case is 192.168.11/24. And the third firewall internal network has also to be unique, which in my case it is, with the address of 192.168.12/24. Now that we made sure that there are no overlapping IP addresses on any of our systems, let's begin the VPN configuration. I've chosen OPNSense 1 to be my OpenVPN server. So to start its configuration, go to VPN, OpenVPN servers. You can go through a wizard and set it up, but we're going to use a manual option. Click Add, as I did just a second ago. Give it a proper description because the same description will be displayed in the Interfaces section and Gateway section. I don't want to create an SSL certificate for the purposes of this video, so I'll use a shared key. Leave protocol on UDP and device mode as tunnel. In my case, I'll leave it as any. Don't forget to change your local port from default to something else, so that internet bots will not be able to figure out easily what service you're running on that port. I always like to use bash random number generator for that, so I don't have to come up with a number. In the section with cryptographic settings, we want to leave automatically generate a shared key option on. Then I strongly recommend changing the default encryption algorithm to something better, like AES256CBC. And I usually use SHA-512 as my authentication algorithm. Now choose your hardware acceleration option if anything shows up here. Keep in mind that if you have any VPN connection problems or anything like that, try disabling the hardware acceleration. The tunnel network is the network that's going to be used for two remote firewalls to talk to each other. I usually keep those in 172 range. 172.16.0.0/24 in this case. I'm not using IPv6, so I'm not going to touch this configuration. And neither I will touch this option because we don't need it in peer-to-peer situation. Now specify our IPv4 local network, which is in my case 192.168.10.0/24. Then for the remote network, specify 192.168.11.0/24. Because this is a network that's located in our pfSense box, as you can see right here. If you have any more local or remote networks, just specify them in the appropriate field and separate them using commas. Like for example, if we had 10.1.1/24 address on this side, I'll just separate them with comma and type in 10.1.1.0/24. Moving on. I don't recommend putting any number in here unless you know what you're doing, because firewalls can open multiple connections in case of a connection failure, and you may be in trouble because of setting the limit on connections. When you are setting up the tunnel between pfSense and OPNSense, they are using different compression algorithms by default, so you'll have to specify one here. Enabled with adaptive compression works the best in my experience. So I'm gonna disable IPv6. No need to touch anything in here. And for now, this is all we have to do on our server side. Except we gotta open the port 242 on our WAN side. So action pass, apply immediately on match, direction in, protocol UDP, source any, destination this firewall, destination port range 242. OpenVPN is a pretty secure VPN software, but if you want to prevent other people from even looking at your ports, you can also filter down the source. This, of course, will only work if the machine on the other side has static IP assigned to it. Give it some description. Hit apply changes. Now let's move on to pfSense. Go to VPN, OpenVPN, Clients, and press Add. Server mode is peer-to-peer shared key. Protocol is UDP. Device mode is tunnel. Interface any for the redundancy reasons. But if you want to filter it down, choose one of your WAN interfaces. Do not specify anything on the local port side unless you know what you're doing. Server or host address is our OPNSense OpenVPN server. Now specify the server port, which is 242 in our case. There is no proxy in between. And give it a description. Now over at cryptographic settings, remove the automatically generate a shared key option. Go back to our server firewall. Edit the OpenVPN server connection and copy the shared key that's been generated on it earlier. Use the same encryption algorithm. Remove the enable NPC option. Use SHA-512 for the authentication, and enable hardware acceleration if the option is available. Now for the IPv4 tunnel network, use the same network that you specified over here. Now the IPv4 remote networks. Go back to our server and copy local network field, because for our pfSense, OPNSense is the remote. You can limit your outgoing bandwidth if you need to. Now the compression option, and as I told you before, we have to choose the adaptive LZO compression. They have different names on these interfaces, but they are basically the same thing. Leave everything as default until here, but activate the flag for gateway creation. In my case, I'll choose IPv4 only. And now hit save. On your OPNSense machine, go to OpenVPN connection status, and as you can see, we are successfully connected. Unfortunately, that's not all that we have to do at this point. And this can be very confusing for new pfSense or OPNSense users. Gateway will be created for us automatically, but there's no interface at the moment that will act as our OPNSense gateway. And as I said earlier, the description that you gave your VPN connection would be your interface name. If you don't know where to find this, go to Interfaces, Assignments. Now check your available ports and choose the OpenVPN connection you've just created. Hit Add. Once interface is added, go and change its settings. We want to enable the interface and give it a proper name. That's all we have to do here. Save, apply, and you're good to go. Now we have to do the same on the OPNSense. Go to Interfaces, Assignments, and we've got a new interface in here. Once interface is added, go ahead and enable it. We don't need to touch anything, just press Save. And apply changes. Now, firewall rules for OpenVPN are a bit tricky. All of the rules for OpenVPN are managed from this OpenVPN interface on both firewalls, OPNSense and pfSense. So to allow traffic between firewalls, you will have to add a rule here. For demonstration purposes, I'll add the wide open rule between two firewalls. It means that anything from firewall A can go to firewall B. The action is pass, interface OpenVPN, direction in, IP version 4, protocol any, source any, destination any. Hit save and apply changes. Go to pfSense, firewall, rules, and as you can see, we have the same OpenVPN interface in here. Again, new rule, pass, interface OpenVPN, address family IPv4, protocol any, source any, destination any. Hit save. Apply changes. Now that everything is done, we have to reload the OpenVPN service in order for it to realize that there is a new gateway between these two firewalls. On the pfSense, go to Status, OpenVPN, and hit this Restart OpenVPN Service. On OPNSense, go to VPN, OpenVPN, Connection Status, and restart the service. Then we can refresh the page to see if the connection has been initiated. For some reason, my pfSense box is showing that nothing is going through, but it has picked up the interface and it's showing that interface is up. Alright, but from looking at gateways, I can see that the gateway is offline. Let's try to fix that. Alright, so after the short digging, I've realized that I've made two mistakes in this setup. And they both happened on the OPNSense side. So first of all, to allow OpenVPN traffic on the WAN interface, you have to add the rule into the floating tab instead of interface tab. Don't mind the port number, I've changed it for testing purposes. So the floating firewall rule on the OPNSense should look like this. Action pass, apply action immediately on match interface, choose the appropriate interface here. Direction, instead of in, choose any. TCP IP version 4 protocol UDP, source any, destination this firewall, and then your port. You can give it a description if you want. Hit save, apply, and you're basically good to go. The other mistake I've made was in the server section. For the protocol, instead of UDP, I had to choose the UDP4. But that's pretty much all you have to do to make this all work. Now on the client side, to check if you have a proper connection, go to Status, OpenVPN, and as you can see here, the connection is active. Another note is that pfSense often hangs on the OpenVPN setup, and if you see that in Status OpenVPN connection is active, but gateway is down, it means that you have to go to interfaces, choose your interface, do not change anything, and then hit save, apply. Then also go to system routing, edit the OpenVPN gateway, just hit save and apply. Do not change anything. This forces pfSense to reload the configuration and gateway should become available anytime soon. After you reload the service, of course. And as you can see, our gateway is up. Alright, so now that we have connection between two firewalls, let's check if our VMs can ping each other. And indeed they can. This FreeBSD VM over here is connected to our OPNSense firewall 1, and it can successfully ping 192.168.11.1, which is our Debian machine. That is connected to pfSense box. And we can also do the same from the Debian machine. So to establish the VPN connection, both firewalls will use the WAN interface. But then to route the traffic between two VMs, they will use the OpenVPN interface. As you can see from states here. Interface, site-to-site, OPNSense 1, protocol ICMP, and then what going where. So if you want to create few rules to limit the traffic going back and forth, it's going to be this interface that you will have to use. As a small example, we can add a reject rule to deny a ping. Now let's specify our source and destination address. Now, after that rule is created, if we try to ping the VM again, it fails. We cannot do so. pfSense is blocking our access. We just sent few ping packets for 3 kilobytes and it declined them. Let's do it again. And nothing. Now from the Debian side, we are still able to ping because the filtering is happening on the OPNSense side. So it is only incoming connection that is affected by this rule. Now let's look at our different scenario for connecting OPNSense 1 to OPNSense 2. On the OPNSense server, go to OpenVPN servers and create the same server as you did for pfSense. I'll just repeat the process and fast forward the video so I don't waste your time. For the IPv4 tunnel network here, we have to choose something different. That's why I went for 172.16.1 instead of a 0. This is a crucial part if you want to have multiple VPN tunnels to your OPNSense box. Now again, go to Firewall, Rules, Floating, copy this rule and change the port to a new one. Now it's time to configure our OPNSense 2 to act as a client. Give it a description. Server mode is peer-to-peer shared key protocol UDP4. Device mode tunnel interface any or choose the appropriate interface. This is a very neat option to activate if you have a dynamic DNS record configured on your server firewall. Just keep in mind it will generate more traffic, so it's not desirable on slow connections. We don't need local port, we don't need username password. And we don't want to generate the key automatically. We want to copy it over from our server. Now, as usual, I'm just matching the server side settings. After our client has been created, let's go to connection status. I had to wait like 10 to 15 seconds, and as you can see, it is now connected. Now we have to repeat the same exact operation with interface, gateway, and firewall rules. Action pass, quick, interface OpenVPN, direction in, TCP version 4, protocol any, source any, destination any. Hit save. Apply changes. Now go to interfaces, assignments, and create a new interface. Edit the interface, enable it, and press save. Apply changes. Do the same on the server side. After our interface is added, let's go to gateways and check if the gateway is there. And here you can see a bright example of quick configuration. I forgot to pick create the gateway option on the server side. Let's fix that real quick. Give our new gateway a name. Choose the appropriate interface, which is in our case Site2Site OPNSense 2. Address family IPv4. You don't have to specify any IP address. Untick disable gateway monitoring and press save. Now press apply changes. Now that you did that, you can see that it has no priority and the status is pending. In order to fix that, go to VPN connection status and restart the server. On our client side, go to gateways, single, click on our new gateway to edit it, and remove the disable gateway monitoring. Hit apply changes. As you can see on our client side, gateway is up and running. On the server side, connection is up. And once I've enabled the gateway again, it started working. Now it's time to get back to our VMs and check if the tunnel works. And as you can see, both machines can talk to each other successfully. Thank you very much for watching. In case you have any questions, leave them down in the comments below, and I'll see you in the next video.